Good evening. I'm Shiva Shankari. I'm a PMRF scholar working in IIT Madras. I'm the person who is handling this live session, NPTEL live session for the course Biological Process Design. Uh, from But today, like since no one has joined the meeting, I'll just make the presentation and uh, like upload it in the video in the YouTube so that like it can be used as a reference for people who want to use it for later purposes. So, as I have introduced myself, I am Shiva Shankari, and this is the sixth live hour session. It had to be like live, but since no students has joined, like this is going to be a recorded version. So first, I'll start with my presentation, solving some few questions. First, I'll explain about some concepts. Then later on, I will start moving to some questions which I have prepared earlier. Welcome to live session 7. The course code is NOC 24 C6 CH06. So first, to begin with, in last class, first I would like to tell what are the things that was handled by the professor for the last week. So it was basically sludge management MBBR and sludge management MBBR, aerobic anaerobic processes and anaerobic processes and mainly the things involved with sludge management. So, first I'll explain what is anaerobic and anaerobic processes and why it is used for sludge management. So, for coming to aerobic process, in case of aerobic process, what happens is the dissolved contaminants present in the water or maybe in the sludge itself is consumed by the bacteria as a food. So this contaminants actually act as a food for the microorganism. So this acts as a food. Acts as food for microorganisms. And since the bacteria is aerobic, it requires oxygen intake and some of the nutrients like nitrogen and phosphorus for building their bodies. We know this nitrogen and phosphorus nutrients in aerobic system is required to some percentage for the bacteria to build up their own body masses. So after the what they do is they just consume these things and build up in masses. So because of that, this organic contaminants is converted to carbon dioxide and excess cell mass is produced along with some water. So that will be the concept. So, thing is in case of aerobic bacteria, the yield will be high since the number of ATPs produced in case of aerobic decomposition or aerobic growth, the number of ATPs produced by aerobic bacteria will be very high. So, compared to anaerobic bacteria. So because of this, the process of growth will be very high. So the yield will be around zero point 0.4 to zero point 0.5. For example, if we give 10 kg of if we give 10 kg of organic pollutant to the bacteria, it can eat and produce zero point 0.4 to zero point 0.5 kg of bacteria. So that will be the concept. I will write it down. Yield is around 0.4 to 0.5. So that is the thing. But when it comes to anaerobic processes, and one more thing is, in case of aerobic bacteria, all these steps will be done by a single. It can be done by a single kind of bacteria to produce the end products. But in case of anaerobic process, it is a sequential. It requires a sequential species, by combination of different bacteria at different stages. One second. Hello, Bhupender Singh.
Hi, good evening, ma'am.
Good evening. Good evening. Am I audible?
Yes, yes, you are.
Okay, fine. Thing is, since no one joined, I started recording the session by explaining this aerobic and anaerobic process. But since you have joined, maybe I'll move to the questions. Is it fine?
Yeah, it's fine.
Okay. So the first question is, in MBBR technology, that is moving bed bioreactor technology, can be applied to option A aerobic systems, option B anaerobic systems, option C anoxic
Clearly not
systems.
audible.
Oh, okay, okay, sorry. One second. Now is it visible?
Yeah, it's now it's visual.
Okay. So the first question is, in moving bed biomembrane bioreactor technology can be applied to, first is aerobic process, second is anaerobic
Aerob
process. Huh?
aerobic.
No, no, no. Just think and tell me. Aerobic process, anaerobic process, anoxic process, or all of these.
It's aerobic.
It is all of these, I guess.
Can you explain a little bit about this? Why it's? I think it's a biological process. So aerobic.
No, no. Biological process can be anaerobic and anoxic as well, right? See,
Okay.
biological bacteria cannot be only aerobic bacteria, right? Even anaerobic bacteria we have, no? And even anoxic bacteria we have. So how can
Okay.
it
Okay.
be like only aerobic?
Okay. So MBVR is can be extended to an anaerobic and this.
Yeah, anoxic things as well. Yeah.
Okay. Okay.
It is just the concept. It is just the this what is this that we call it as that small round things will be there, no, in that the biofilm will be stuck onto that, and and that will be put into the water. So that is the main concept, but it doesn't mean that it can only be for aerobic, because we have this anaerobic bacteria, anoxic bacteria, so this thing can be extended to anything. So that is the thing. Okay,
Okay. Ma'am,
fine.
I'm joining from my laptop, so please allow me. I'm leaving from my from this system.
Okay, okay, no problem, no problem.
Oh,
I'll wait. Yeah.
yes,
Okay, fine. Have you joined?
yes, ma'am. You can.
Okay, okay,
Yes, yes, I have joined.
okay, okay. So the answer is all of these. Okay, so next question is which of the following methods are not used for pathogen destruction? First one is composting, second one is chemical treatment, third one is mechanical stirring, fourth one is thermophilic digestion.
Chemical steering, mechanical steering,
Mechanical stirring. Yeah, mechanical stirring is correct answer. Because in case of composting, what you will be doing is you will be adding bacteria, and at the end of the day, um, like all the compost produced will be stabilized one, which is not containing any sort of pathogens. So composting, it will not come. Then chemical treatment, we'll be adding some chemicals by which the pathogens will get died, so that also won't be the answer. For thermophilic digestion, again, thermophilic bacteria will be acting and heat will be generated, because of which the pathogens will go to death. So the answer is mechanical stirring, because just by mechanical stirring you won't be able to generate any sort of thing that will kill pathogens. So the answer is mechanical stirring. Okay. Next question is which gas is produced in aerobic digestion of sludge? NO2, CO2, O2, H2S.
NO2 and H2S.
In aerobic digestion, think and tell me, in aerobic digestion what will happen?
NO2.
Uh, Aerobic digestion, see here. In case of aerobic digestion, what will happen? I'll go to the first slide. CO2 is
So
produced
basically,
now. How will hydrogen sulfide and NO2 will be produced?
in case of the aerobic digestion, so nitrification happened. That's why I chose this.
Okay, but more than that, CO2 will be produced. Now, how will nitrogen, NO2 won't be produced? See here, what is happening in aerobic digestion is organic contaminants will be taken in, and the nutrients will be, nitrification means see, the nutrients will be, nitrifiers will be there, but very less quantity will be there. Aerobic digestion, mostly heterotrophs will be consuming nitrogen. They will take in nitrogen to produce their cell masses. They won't produce NO2. That is the thing. So,
Okay.
yeah. If you take carbon removal, the what will happen is the carbon removing heterotrophs in case of ASP will be dominant. Okay, what you are telling is like for nitrification. Okay, nitrifiers will be present in very minimal quantity for this case of what is this for this case of ASP and all. Nitrifiers will be present in very less quantity. Okay, and they are autotrophs, they are not heterotrophs. Okay, so nitrifying bacteria are autotrophs, that is, they will take the alkalinity, they won't take this consume organic contaminants. Okay, so dominantly what will happen is this organic contaminants will be used by the heterotrophic bacteria to produce carbon dioxide and cell masses. While producing cell mass, some quantity of nitrogen also will be taken by the heterotrophs. Okay, but it won't be converted to NO2. What you are telling is for nitrifiers. For nitrifiers, it can do. Yeah. Is it fine?
Okay. Yeah, it's fine.
So the answer will be CO2. Because NO2 cannot be produced, CO2 will be produced. O2 is consumed, it's not produced. Hydrogen sulfide will not be produced in case of aerobic digestion. Excuse me. Okay. Which of the following process is not involved in the treatment of sludge? First one is dewatering, second one is drying, flocculation, and conditioning.
Conditioning.
Conditioning, I don't think that is the correct answer. How will you, like,
Okay.
we won't flocculate a sledge, right? We
Yes.
may coagulate the sledge. I don't think we will never flocculate the sledge, na. See, dewatering you can do just by removing the water. Drying also you can do. Conditioning in sense like you will add some chemicals for conditioning, like lime or something. Either
Like in
yeah.
like the before the dewatering stage, like the before the formation of the sludge, or maybe the settling of the sludge, the 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 stage which happened is flocculation. So that's why I think I choose this flocculation.
No.
It's before.
Flocculation is not correct answer. Conditioning is like, see, conditioning is you will add some sort of chemicals like lime, like at excessive alkaline condition and all, this pathogens will get died. Okay, so that is called as chemical conditioning. So that can be used as a treatment for sludge. Flocculation cannot be used as a treatment for sludge.
Okay.
Yeah, so that is the thing. Okay. Flocculation means you will be using the flocculator that uh, this will be there, no? This sort of stirrers will be there, and you'll be flocculating it to form bigger flocks. That cannot be used for sludge. Can be used for water only to remove the colloidal particles. If colloidal particles are there in water, we may add the coagulant to stabilize the colloidal particles to remove the negative charge around this colloidal particles and bring the particles together by flocculating. So flocks will be formed, and because of that, just it can be settled. That is the thing. Colloidal particles cannot be settled as such without adding coagulants. So we will add coagulants to like to destabilize them, and then we will just uh, flocculate it to form bigger flocks and then settle it down. So that is flocculation. It cannot be used for sledge treatment. Is it fine?
Yeah, it's fine.
Okay, chalo. Now we'll move to next question. Okay, so the next question is, in anaerobic sludge digestion tank, the gas that mainly evolves is option A, methane.
Methane.
Yeah, methane is correct. Option B, hydrogen sulfide. Option C, ammonia. Option D, nitrogen. So the answer will be methane.
Methane.
Because in case of anaerobic digestion, what happens is reduction of this carbon, organic carbon that is coming in will be taking place. So the organic contaminant will produce methane as a major this thing by the methanogenic uh, by the by the anaerobic bacteria. Methanogens, that is at the last stage of anaerobic digestion, methanogens will be present, and the methanogens will produce methane. The next question is the sludge treatment process. Uh, the sludge treatment process to increase the solid content of sludges, to increase the solid content of the sludge means like you are going to remove some water and then increase the uh, uh, solid content. So it is dewatering, drying, conditioning, thickening. Can you guess the answer? Okay, I'll give 2 minutes time. Just think and tell me.
Drying.
Drying. It's
It's the
thickening.
what thickening book.
It's thickening. Okay, not drying. The correct sequence of sludge digestion steps is option A methanogenesis, acidogenesis, hydrolysis. Option B acidogenesis, methanogenesis, pyrolysis. Option C hydrolysis, acidogenesis, methanogenesis. Option D hydrolysis, methanogenesis, acidogenesis. I'll give 2 minutes time. Just think and tell me.
Okay.
Ah. You can refer your notes also if you have watched the lectures and all.
It's option D.
No, not option D. See here, I explained in the last class. No, the first process will be hydrolysis because the uh, because this higher complex chemical organic compounds will be converted to simpler organic compounds by addition of water. So that will be first step, that is hydrolysis. After that, the organic acids will be produced from the simpler compounds by uh, acid generators. After that, acetic acid or acetate will be converted to methane by methanogenesis, by the methanogens. So that will be the sequence. So option C will be the sequence. If you want, I can type it also. The first step, the first step involved in the anaerobic digestion is hydrolysis, that is conversion of complex organic matter into simpler organic matter by addition of water. Next, the acid formers convert the produced simpler molecules into organic acids like acetic acid. Finally, the methanogens convert the acetate formed into methane. Okay, is it fine?
One minute, ma'am. Yeah, it's fine. I'm taking note, ma'am. So please
Yeah,
go.
yeah, yeah. Okay, okay, no problem. I'll wait. You write it down, no problem.
So this is happening in the anaerobic process now.
Anaerobic process. See, in case of aerobic process, bacteria will do the conversion from organics to CO2. But in case of anaerobic digestion, you will need a sequence of bacteria, series of four bacteria.
Oh,
Okay, first for doing hydrolysis, then acidogenesis, then acetogenesis. One more step will be there, but in this question that is not mentioned. Okay, so after that acetogenesis, then finally this methanogens, methane will be formed from acetate produced. Okay.
okay. So, ma'am, can you explain a little bit about the aerobic process also? So, how this step is happening in the aerobic
This
digester?
see here three or four different species are involved. No, in case of aerobic process,
Yeah.
wait, let me explain again. Thing is, I have explained before you joined the meeting. No, did you note down? Shall I move to that slide? Wait. First, you
Yes,
note
yes,
down.
you can move.
Okay, okay, fine. So, in case of aerobic process, what happens is only a single type of bacteria can do this aerobic treatment. That is, the conversion from organic contaminants to CO2 can be done by a single bacteria itself. But for case of anaerobic bacteria, what you need is you need some 3 4 microorganisms working together. It is like a family working together to produce methane. Simply one bacteria alone cannot survive and produce methane, the required end product. So, in case of aerobic bacteria, what happens is the organic contaminants are taken in by the aerobic bacteria in presence of oxygen, and they also take in nutrients. Nutrients means like nitrogen and phosphorus to build their body masses. This nitrogen and phosphorus are used for only bodybuilding and for functioning. It is not like converted to some other thing. So, in case of heterotrophs, only very little amount of nitrogen can be removed, and mostly the removal will be carbon removal because that is getting converted to CO2. Okay, and the yield will be about 0.4 to 0.5. That is, for example, if you give about 10 kg of organic contaminant, then for that 0.4 to 0.5 kg of bacteria can be produced. So that is called as yield. That is ds by d dx by ds. So that is the yield. So that I would have explained in the biokinetic parameters and all. So if we give how much, how if we give some amount of substrate, that is organic contaminant, to the bacteria, how much cells it can produce, that is called as yield. So if, for example, if we give 10 kg of a substrate, it can produce zero point 0.4 to point I mean 4 to 5 kg of bacteria. In case of aerobic bacteria, the ATPs produced will be high, so they will have very high yield. But when it comes to anaerobic bacteria, the yield of the cell will be very less. The yield of the cell will be like around zero point 0.1 to zero point 0.2 only. So the sludge production will be very minimal. So here the nutrient intake, but compared to aerobic bacteria, the nutrient intake or requirement for anaerobic bacteria will be very minimal. So comparatively, the amount of nitrogen and phosphorus removed in case of aerobic bacteria will be very high compared to nitrogen and phosphorus or nutrients removed by anaerobic bacteria. So at the end, aerobic bacteria will produce carbon dioxide and anaerobic bacteria will produce methane. Is it fine, or should I type all the things which I told?
Yeah, it's fine, ma'am.
Okay, fine. So now I'll move to the next question.
Ma'am, I have one more question. So, in case of aerobic bioreactors, so we measures the health of the microorganisms by the MLSS and MLBSS check. So, in case of anaerobic digesters, so how we can check, yeah, evaluate the health of the reactor? So can you
There
little bit
also you
explain
can
about this
measure the
also?
MLSs. You
Okay.
can
So
measure
same
it.
process can be.
Yeah. You can measure it. You can measure it. See, it's at the end how much sludge is produced. That is how much volume of bacteria is produced, right? So that can be, MLSs can be used for measuring. It is ultimately the suspended solids. No, whatever it is, anaerobic bacteria or aerobic bacteria. The concept is you are giving some sort of dissolved pollutant organic, and it is getting converted to bacteria, that is suspended form of organics. So you can use MLSS and MLVSS concept for anaerobic bacteria also to evaluate. That won't be an issue. is it
Okay.
is it fine?
Yeah, it's fine.
Okay, sorry, I'll move to next question. Okay, so the next question is, which among the following radiation is not used to reduce pathogens in sludge? Option A, gamma rays. Option B, UV rays. Option C, beta rays. Option D, radio waves. Think and tell me. I will give some.
Radio waves.
Radio waves. Yeah, because all these three waves, all these gamma waves, UV rays, and beta rays have higher frequency, higher energy frequency, and that can destroy the cell wall of the bacteria, uh, uh, to destroy the bacteria or pathogens. Especially UV 254, at 254 nanometer, disinfection happens at very at wavelength of UV equal to 254 nanometer. This disinfection process is very good because the bacterial wall gets rupture uh, at that wavelength. But radio waves is a wave that is having very less energy compared to all these things. Radio waves have less wavelength. I mean, have uh, higher, lower frequency and longer wavelength, so that cannot be used for destroying bacteria or pathogens and cannot be used for disinfection processes. So that is the thing. So moving to next question, the ideal C by N ratio for sewage sludge composting ranges between option A 28 to 35, option B 14 to 23, option C 10 to 15, option D 26 to 31. Think and tell me. I'll give 2 minutes time.
Option D.
Option D. Yeah, it is correct answer. Do you know why?
No, ma'am, you can explain.
Okay, see, thing is C by N ratio should be optimum. It should not be too less or too high for the bacteria to produce this thing. So this optimal range will lie between 26 to 31. So that is the thing. Okay. It should not be too less or too high. So next question is, in dash process the products are generally carbon dioxide and water. Option A anaerobic process, option B facultative process, option C aerobic process, option D anoxic process.
Aerobic, ma'am.
The answer is aerobic. Because this I have explained several times. So yeah. Okay. So I have two problems for today. One thing will be a big problem, but thing is like I don't think that will be asked from exam point of view. I just bought it uh, to explain something conceptually based on some like design work I did for my coursework. So based on that, I just wanted to explain that. So before that, we have one more question. Um, so this will be a simple question which you can solve. Second question will be a bit bigger question, and I'll explain like how I worked it out during my coursework. Well, when I was studying this biological process design during my PhD coursework. So first question is, if one third of the solid matter in a sludge containing 90% of water is composed of fixed mineral solids with specific gravity of 2.5 and two-thirds is composed of volatile solids with specific gravity as 1, find out the specific gravity of solids SS and specific gravity of the sludge. So first step will be we have to find the specific gravity of the solids separately, and second step is we have to find the specific gravity of the sludge separately. Okay. So uh, can you write the given data, Bhupender?
I'm writing, ma'am. Please,
Yeah,
one
I'll
minute.
wait. I'll wait. You write the given data. I'll tell you the formula and how to substitute it. Then you solve and tell me the answer you are getting. Okay.
Okay. I have write it down, ma'am. You can
Okay,
proceed
okay,
further.
fine, fine, fine. Okay, I'll show the formula alone for you. I won't show the answer. So, see, the weight of solids, basically, this is how you have to find it. A specific gravity, general formula, okay? The specific gravity, weight of uh, anything that has to be found divided by specific gravity into density of water is equal to like this thing, this fraction you have to apply for multiple things. Okay, so for solids the formula will become like weight of solids, that I mean like the specific gravity of solids, that's what you have to find it out. Okay, so it is weight of solids divided by specific gravity of solids divided by density of water is equal to weight of fixed solids divided by specific gravity of fixed solids divided by density of water plus weight of volatile solids divided by specific gravity of volatile solids divided by density of water. Okay, but thing is density of water is constant in all the thing, Hana. So just cancel it out. So the equation will now become as weight of solids divided by specific gravity of solids is equal to weight of fixed solids divided by specific gravity of fixed solids plus weight of volatile solids divided by specific gravity of volatile solids. So now you know the given data. Just make the substitutions and tell me the answer. I will give 2 minutes. I will give 5 minutes time.
Ma'am, I'm not able to solve this. Can you?
Okay, okay, okay. I will explain. Wait. See here. Weight of fixed, see here. There is some amount of solids. Okay. So, in that, one third of the solid matter in the sludge containing 90% of water. Okay. So, Wait, I will just type it down for you for easy understanding. First, read the question carefully and then you will be able to answer it. It is not that difficult. Okay. So it's easy only. You can understand. It will be easy. So see here. First, it is given that in one third of solid matter in a sludge containing 90% of water is composed of fixed mineral solids with specific gravity 2.5. Okay. So thing is it is given that containing 90% of water. Okay. So sludge contains 90% in weight of water. Okay, so what will be the percentage of solids in the sludge? Mm, can you tell me what will be the percentage of solids if 90% is in a sludge is water? What will be the percentage of solids in the sludge?
10%.
10%. So it is 100 minus 90 percentage in weight. Sorry, sludge contains 90% in weight of water. Sludge contains in weight solids. Okay, so this is the thing. So now you know the weight of solids, that is weight of solids and the weight of water. So you know the data for this. This will be 90% and this sorry, this will be 10% and this will be 90%. This solids, a specific gravity of solids, we have to get from this one. So for this we should know what is the percentage of fixed solids and what is the percentage of volatile solids. Now in the question it is given as one third of the solid matter is fixed solids. Okay, and two thirds is composed of volatile solids with specific gravity equal to 1. Are you getting my point?
Yes, yes, I am getting.
Okay, so one third means 33% of the solids present in the sludge contains fixed solids and the remaining 67%, it is actually 33.333 and 66.666 something will come. So I have just approximated the values. Okay, of solids present in the sludge contains volatile solids. Okay, so here weight of solids you assume it as 100. Okay, if you assume 100 kg is there, in that fixed solids will be how many kgs? Bhupender,
It's 1/3.
fixed solids will be 1 by 3. Yeah, so it is 33. Okay, and for volatile solids it will be 67. And you know the specific gravity of fixed solids, it is given as 2.5, and for volatile solids it is given as 1. Okay, so now I have told all the data. Now you make the substitutions and tell me. Okay, wait. This you assume it as 100 or 1 or whatever it is, but write the percentage carefully. So if you take 100 kg of solids are present, in that fixed solids will be 33% and volatile solids will be 67%. specific gravity of solids. This is what you have to find out. Okay, fixed solids will have a specific gravity of 2.5 and volatile solids will have specific gravity of 1. So now you solve this and tell me what will be the specific gravity of solids first of all. Then we will go to what will be the specific gravity of sludge. You solve and tell me what will be the answer. I will wait. Okay.
Is point 0.6.
No, no, no. Zero point 0.6 won't be the answer, Bhupender. I was getting 1.24 or something. How did you make the substitutions? Tell me. See here. First it is, let me check the calculations. So 33 divided by 2.5. Okay. It is 13.2 plus 67. Okay. It is 80.2. Okay. So now I'm getting, like, how much I'm getting is like, wait, I will write it down. So for this, 100 divided by specific gravity of solids is equal to 80.2.
Yeah, yes.
Okay. So specific gravity of solids will go this side and 80.2 will come down. Anna. So now you tell me the
Yes,
answer.
yes. Yeah, it's 1.25.
1.24. Yeah, that was the answer I was also getting. Where did you make the mistake by the way? In which substitution did you make the mistake?
I made a mistake in calculation actually. So now I have corrected it.
Okay, 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 okay. No problem. Chalo. Now you make the substitutions for the second step and tell me the answer. I have shown you the given data and all, no? Like just try to apply the substitutions and tell me what will be the specific gravity of the sludge. Now you know the specific gravity of solids. It is 1.24 or 25 from the previous step. Just apply it in the next thing along with the percentage of weight of sludge and everything and tell me what will be the answer. One second, someone has joined the meeting. Hi, Punita. Hello, Punita. Am I audible?
Yes, ma'am.
Okay. So we were solving a question. If you want, like, you can join. I can explain the question. Do you want me to explain the question? Punita? Punita?
Yes.
Do you want me to explain the question? You want to solve the problem or you just came for listening? Bhupender, did you get the answer by the way?
I'm trying.
Okay, try. Take your own time, no problem. Punita, you want me to explain the problem? Okay, fine. Punita, if you want, you can tell me. Like, I'll just read the question and I'll tell you how to substitute and all. So that, like, only if you want, because I have already explained for Bhupender. So that is it.
Ma'am, one time explain பண்ணுங்க ma'am.
Okay. I will explain. Okay. See here, Punita. Uh, if one, if this is the question, okay? If one third of the solid matter in a sludge containing 90% of water is composed of fixed solids with a specific gravity of 2.5 and two thirds is composed of volatile solids with a specific gravity of 1. Find out what will be the specific gravity of solids and what will be the specific gravity of the sludge. Okay. So thing is, now first step will be to find the specific gravity of solids. Okay. So in the question, if you see what is given in the question, 90% of the sludge contains water. It is given here, right? Punita?
Yes, ma'am.
So what will be the percentage of solids? Given 90% of the sludge contains water. Okay. So what will be the percentage of solids, Punita?
10% ma'am.
10 percentage, correct. Okay. So 10 percentage of solids will be present in the sludge. Okay. So this is the first thing. Okay. Then second is, like, if one third of the solid matter in that 10% solids, one third, see, there is totally some solids. Okay. In that one third of the solid matter is composed of fixed solids. Okay, va. Appo, when it comes to volatile solids, it contains two thirds. Okay. So one third in sense 33% of the solids or fixed solids and the remaining 67% of solids will be volatile solids. Okay. Puridada.
Okay, ma'am.
You're
புரியுது
getting
ma'am.
okay. So you're getting it right. So now that is the thing I have wrote here also. Okay. So now this will be the formula. The formula will be in general. This is how you have to write. Okay. One second. The weight of the thing for which you have to find the specific gravity divided by the specific gravity of the thing for which specific gravity is to be determined into this density of water is equal to weight of fixed the same fraction will be applied for its constituents. Okay, so if we see solids, it has both fixed solids and volatile solids. So the formula application will be like weight of solids divided by specific gravity of solids into density of water is equal to weight of fixed solids divided by specific gravity of fixed solids into rho W plus weight of volatile solids divided by specific gravity of volatile solids into rho W. So this will be the concept. Okay, now you make the substitutions. Okay, if you assume 100 kg of solids is present, in that 33 percentage will be fixed solids. So 33 I have put 33 for this thing. And for volatile solids, if you apply similarly, weight of volatile solids will be 67. So if you put a specific gravity of fixed solids, it is given in the question as 2.5, and for volatile solids it is given as 1. Now can you make the substitution and tell me what will be the specific gravity of solids, Punita? Punita,
Yes ma'am.
just make the substitutions and tell me. You have understood what I have explained, right?
Okay ma'am.
Make the substitutions and tell me the answer. What will be the specific gravity of solids? I have wrote the numbers also. Just do the calculation and tell me the answer. Okay.
Okay ma'am.
Okay. I'll give 2 minutes time. Bhupender, have you completed this one?
It's coming at 1.02, ma'am.
1.02. It is correct. Okay. Bhupender, will you wait for 2 minutes so that Punita can also join it? Join the
Oh,
join for the next problem. Okay. Can you wait for some 5 minutes so
yeah,
that
yes. Yeah.
you
Yes.
tell me the
No issue,
answer,
ma'am.
Punita, when you have completed this thing.
Okay ma'am.
Yeah, I'll give some 3 minutes. You just make the substitutions and tell me.
Ma'am,
Huh? What?
1.24, ma'am, answer.
1.24. Super. Okay, correct. Now you apply this concept for the second step and tell me the answer. Okay. Assume the weight of the sledge is equal to 100. Wait, I'll write it down for you also. Weight
Ma'am,
of so this will be 1.24. Weight of solids is 10%.
okay, ma'am.
Water is 90.
Okay, ma'am.
Now solids density, what is given? That is no, this one you have to find out. Sorry. Solid specific gravity only we have found out from the previous step. It is 1.24. Specific gravity of water is 1. Now you make the substitutions and tell me what will be the answer for this. I'll give some 2 minutes time. Okay. After that, we will move to next question. Okay. Bhupender is waiting, so just make the calculations quickly and tell me the answer.
Ma'am, answer is 1, ma'am.
1.02 something, Punita.
Yes, ma'am.
Okay, okay.
1.02.
Yeah. It is fine. Okay, now we will
Okay,
move
ma'am.
to the next thing. Okay, so this one is not actually a part of your curriculum. I just wanted to explain something about like a design work which I did for my coursework. So thing is, we were given a task like we had to design an entire treatment system, treatment unit for our locality. So I am residing in Virudhunagar. Based on the population data, forecasting everything had to be done, and I had to design this overall treatment schematics. But in this thing, I'm not going to explain everything. For this, you just have to find the volume of the primary and secondary sludge. Okay. So here first I'll explain the schematics. Okay. So what I have done is I have given the influent water to sump well. From that it will reach the approach channel. Then it will go to the grid chamber, screen chamber. Then grid removal will take place, and then I have given offline equalization. From there, it will go to primary clarifier. Okay, so this is the main thing, primary clarifier. In this primary clarifier, two things can be removed. Okay, the first one is suspended solids from the influent and little bit of BOD. Okay, not too much BOD, but little bit of BOD can be removed in primary settling tank. Okay, so after doing primary settling, then it will go to secondary treatment. So for secondary treatment, I have done MBBR design, in which I have given two stages. So first stage will be carbon removal, second stage will be nitrification, and along with that I have given a anoxic tank for denitrification. So after that it will go to the secondary sedimentation tank. So this is also important. Okay, in case of secondary settling tank, settling tank also sludge will be produced. Okay, so thing is, the concept is sludge will be produced from primary settling tank and sludge will be produced from secondary settling tank as well. 1 second, let's join the meeting. Hi Sunny, am I audible?
Yes, ma'am.
Okay, so we have discussed all the problems and MCQs. So I will just explain. I was explaining them like thing that is apart from the curriculum. So I just want to continue with that. So if you want, after this I can explain you the MCQs and previous things, or you can watch the recorded session. The session is also getting recorded. Okay, but now I'll go with this question. So that is the thing. So in case of primary sedimentation tank also some sludge will be produced, and in case of secondary settling tank also some sludge will be produced. So now your task is just to calculate the volume of the primary sludge and the volume of the secondary sludge that is getting produced. Okay, thing is, primary sludge will go to blender, secondary sludge will be sent to a gravity thickener and then sent to a blender. Okay, and in the blender both primary and secondary settling I mean the sludges will be blended together and sent to anaerobic digester, and after that after the digestion takes place, I'm going to send it to the drying bed. So that is how the sludge management will be taking place. So thing is, now we have to find the volume of the primary and the secondary sludge alone. Okay, so that is the thing. So given the flow of wastewater, that is Q equal to 9.51968 mld, and the suspended solids in the influent is equal to 300 mg per liter. Solids removal efficiency in primary settling tank is equal to 0.9. BOD influent is 350. BOD effluent from secondary clarifier is 10. BOD removal efficiency at PST is 34%, that is 0.34. Biomass conversion factor from MBBR is equal to 0.4. Okay, so for finding the volume of sludge, you have to use this formula: mass of sludge divided by specific gravity of sludge divided by 1000 into percentage of solids divided by 100. Okay, so first, here the influent flow, sorry, the influent flow is 9.51 mld. Okay, suspended solids coming in is it is given as, okay, total suspended solids is 300 mg per liter. Okay, so here suspended solids is equal to 300 mg per liter, and amount of suspended solids that will be removed in primary sedimentation tank is 70%. Okay, so what I told is BOD also will be removed in primary settling tank, and this suspended solids also will be removed. Okay, suspended solids removal in primary settling tank is given as 70%. Hana? So now tell me how much suspended solids will be getting settled at PST? Can someone tell me? You are understanding what I'm explaining, or like it is not understandable for three of you? Bhupender? Okay.
Can you explain it once more?
What happened in the session? Bhupender? Punita?
Yes, ma'am.
You are understanding what I'm telling or not? Bhupender?
Yes, ma'am.
See here. Flow is given. Okay. Influence suspended solids is given. Percentage removal of suspended solids is given. So, what will be the amount of suspended solids produced? Can you tell me? From PST. Is my screen visible? Bhupender, is my screen visible?
Yes, your screen is visual.
Okay. See here, I'll just explain, but you tell me the answers. Okay. Mass of the solids in the influent. How will you find the mass of the solids in the influent? You have given the flow. Okay. Flow is given. Okay. And then you know the suspended solids in the influent. Okay. So mass of the solids in the influent will be flow into this one. If you put, you will get kg per day, no? See here. MLD is nothing but million liters per day. Wait, I will write it down. MLD is million liters per day. Okay. And mg per liter of suspended solids is given. So, to find the mass of suspended solids, what will you do? If you multiply mg per liter, mld, if you mld, you try to convert it into this kg. Okay, see here. Mass equal to flow into concentration. Flow is nothing but it is given in equal to 10 to the power 6. Million is nothing but 6, no? Okay. plus liters per day into mg per liter. Okay. So this liter in denominator and liter in numerator will get cancelled. This MLD, that is million liters per day. Here for flow, the liter is at the numerator, but for concentration, the liter is at the denominator. So these two things will be getting cancelled. So what you will get is equal to 10 to the power 6 mg per day. Correct? Is it fine?
Yeah, it's
Yes,
fine.
ma'am.
Now you are getting what I'm telling?
Yes, ma'am.
Okay. So, which is nothing but now you tell me in kg. Mg per day, how will you convert to kg? Now you do the conversion and tell me 10 to the power 6.
10 raised to power 3 kg per day.
No. It is 1 kg per day, no?
It's 1 kg. Sorry, it's
1
1
kg
kg.
per day. So, 1 kg per day. Okay. So, now you know what is this flow. Okay, it is 9.51 into 300. If you put, you will know what is the total mass of suspended solids from the influent. Hana, this into this
Yes,
will
ma'am.
give you the mass of suspended solids in the influent. Now you tell me the answer. I have solved and kept. So now you just tell me the answer. I will cross verify with this. Just multiply both the things and tell me.
It's 28559.04.
1 second. Correct. 2855 I'm getting. That is okay. Okay. Now we are going to move to the next step. Punita, are you getting the same answer?
Yes, ma'am.
Okay. So now you know what is the mass of solids that is entering. Okay. But PST will remove 70% of the mass of the influent suspended solids. Okay. So PST is nothing but it is settling, right? So 70% of the influent mass of solids is getting settled at the PST. Okay. So what will be the sludge produced by suspended solids in PST? Now tell me. You are getting my point?
Yes, ma'am.
Ah,
It's 1999.1328.
1 second. Ha, it's correct. Punita, you are getting what I am telling?
Ma'am,
Punita?
one time repeat பண்ணுங்க ma'am.
Okay. I will repeat it. No problem. See here. In PST, primary settling tank. Okay. So what is happening is you are giving some influent solids, that will be mass of the solids. Okay, so that you have calculated from the previous step. Okay, but the in primary clarifier what is happening is the solids will get settled. Okay, and the settling efficiency is given as 70%. So means 70% of the solid mass is getting settled. Okay, 70% is getting settled now. What is the sludge produced? Settle ஆவறது தானே will be the sludge. If 70% of the mass is getting settled, what will be the settled sludge produced?
70% of total mass.
Yeah, you are correct, Bhupender.
Ma'am,
Yeah,
ma'am,
tell me.
this 70% is fixed for every primary treatment process, or just
No,
it
no,
can vary on
no,
the
no, no. No,
depending
thing
upon the
is,
chemical use.
yeah. It depends. It depends. It varies. For my design, I have assumed it as 70%. Okay.
For maximum in primary treatment, we are achieving the settling by the use of the chemicals. So I think it's fixed to every type of treatment. No? So it can be
No, I
varied,
don't think it
like
is fixed.
depending upon the grade and the quality of the coagulant flow fluent.
Maybe I'm not aware of that, but for my design, for this entire schematics, I used this. I assumed that thing. Okay, that 70% will get removed. Okay, so I don't know about like real thing, like how it works. Okay,
So how you assume this 70%? You can just I'm
70%.
just trying to.
See, 70% I have assumed because maximum suspended solids will be removed in primary clarifier itself. Okay. So I have taken it as 70% for my design.
Okay.
That is the thing. Punita, you are getting what I explained?
Yes, ma'am.
So now tell me what will be the sludge produced in primary clarifier due to suspended solids? Puridada. Punita,
Yes, ma'am.
you are getting or not like what I have explained?
மேம் பாதி புரிஞ்சுது பாதி புரியல மேம்.
What you are not able to understand, Punita. See here. Here settling is only happening. Okay. It's
ஓகே
just
மேம்.
settling. Okay. So whatever is getting settled, that will be the sludge produced. Okay.
ஓகே மேம்.
But 70% of the solids is getting settled.
ஓகே மேம்.
Okay. So how much will be the sludge produced?
அது வந்து மாஸ் கூட வந்து இன்டு
Into
பண்ணிக்கணுமா மேம்?
70%. Yeah, that's it.
ஓகே மேம்.
Okay. So that will be the
ஓகே
thing.
மேம்.
So if we do that, we will be getting the value as 199.13 kg per day. Okay. So now assume the specific gravity of the primary clarifying sludge is equal to 1.06 and the percentage of solids is 6%. Okay. So now here I'll write down the substitutions and now you can tell me the answer directly. Okay. So mass of sludge will be, you have calculated, right? Mass of sludge will be 1999 and percentage of solids will be 6%. This specific gravity will be 1.06. Okay. So now make the calculation and tell me what will be the volume of the sludge produced. for primary clarifier. That is the first step. That is the first part of this question. Just make the substitutions and tell me the answer.
Thirty-one point four three.
Ma'am, answer is 31.43, ma'am.
Wait, let me check. I think I was also getting something around that only. Check. It is correct. Okay. So now, in a similar way, you have to find the volume of sludge for the secondary clarifier. Okay. So, first thing is BOD into MBBR stage 1 is 229.348. You just write down this value. Just write down this value because this I have taken from my previous this calculations and all. See here, BOD effluent from the secondary clarifier, BOD influent is given as 350 in the question. Okay, and BOD removal efficiency at PST is given as 0.34. So what will be the BOD that is entering MBBR unit? Wait, let me explain. 1 second. See here, the BOD entering is 350. Okay, and at PST, BOD getting removed is 34 percentage. So what will be the BOD that is entering here? MBBR stage. Okay, the same concept you have to apply. Okay, see here, instead of suspended solids, consider BOD equal to 350. Hana? So BOD, but in primary clarifier, how much percentage is getting removed? That I have. In primary, 1 second. BOD removal in PST is equal to 0.34 percentage. Okay, so it is like in a similar way, what will be the mass of BOD that is entering MBBR unit? So it is Q into this BOD, that is 350. So this is 9.51 into 350 into 1 minus BOD removed at primary clarifier, 0.344, right? You are getting my point?
Yes, ma'am.
What will be the BOD at the entry of this stage? What will be the BOD at this stage? See, some BOD is getting removed in PST. The total flow you know, and what is the influent BOD you know, and what is the percentage of BOD that is getting removed in PST you know. Okay, so here what will be the BOD that is entering is equal to, mass of BOD is equal to 350 into 9.51 into 0.7. Sorry, 1 minus 0.344.
It's coming as 1873.536.
1 second. 1 minus 0. Punita, you are getting what I am explaining? Punita,
Yes, ma'am.
you are getting what I am explaining?
Oh, yes, ma'am.
Sure?
Yes, ma'am.
Okay, now tell me the answer. Bhupender, what was the answer?
1873.536 kg per day.
18736. Ha, fine, fine. 1 second. Equal to this into no, Bhupender, I am getting a different answer. How did you make the substitutions? Q is nothing but 9.51, right? Into
Yes.
350.
300.
350, no.
350. Yes,
Ah,
yes, 350.
into 350 into 1 minus 0.344. What is the answer you are getting?
One minute, ma'am.
Punita, you also do the calculation. It is 9.51 into. Punita, you are understanding what I am explaining, or like you want me to explain it once again? Yeah, Bhupender.
2185.72.
Okay. It is correct, Bhupender. Okay. So now we will go to the next step. Okay. BOD consumed in the reactor is minus. See, BOD effluent out of the secondary clarifier, it is 10. BOD out of secondary clarifier, it is 10. Okay. And BOD entering in terms of, don't tell me in terms of kg per day, in terms of this without multiplying 9.51, the answer will be 229, I guess. The Bhupender, can you tell me what will be the answer? 350 into 1 minus 0.344.
1 minute.
350 into 1 minus
is 229.6.
229.6. So 229.6 is entering the MBBR unit and only 10 is going out. So BOD consumed in the MBBR unit will be how much? Bhupender, you are understanding what I am telling? See.
Can you explain it once again?
Yeah, I can explain it. See here, BOD entering the MBBR unit is 229. You have calculated, okay? That is
Yes, ma'am.
350 into 1 minus BOD that is getting removed from the PSG. Right? So it is 350
Yes.
into 1 minus 0.344. That will be the BOD that is entering MBBR unit. Okay? But the effluent from MBBR unit has only 10 mg per liter of BOD. Okay. So what will be the BOD that is
Okay.
consumed inside the MBBR unit? It is 229.6
Is
minus 10, right?
220.6 minus 10.
That is the thing. So it is 219.6. That will be the BOD that is getting consumed by the bacteria inside MBBR unit. Okay. So inside MBBR unit, the bacteria present is eating minus 10 is eating 219.6 mg per liter of BOD. I'll write it down. BOD as the influent of the MBBR unit is equal to 229.6, which is calculated from 350 into 1 minus 0.344. BOD at the effluent of MBBR unit is given as equal to 10 mg per liter. So BOD consumed by the bacteria present inside the MBBR unit is equal to 229.6 minus 10, which is equal to 219.6. Okay, now we will move to the next step. Okay, in this biomass conversion factor is given as 0.4. Okay, so biomass conversion factor is nothing but yield. Okay, so for biomass conversion factor is like if 10.4. Okay, this yield I have explained the yield in the starting of the session itself. No, so if 2196.219.6 mg per okay, 1 second, I just switch on the charge. If 219 9.6 mg per liter of BOD is consumed, that is BOD is eaten by the bacteria, 0.4 times of that kg will be produced. Okay, so that is the biomass conversion factor. You are getting what I'm explaining, Bhupender? Bhupender?
Yes, ma'am.
You are getting what I'm explaining?
Yes, ma'am.
Factor yield equal to 0.4. Meaning, if 1 kg of BOD is given to the microbe, it can produce 0.4 kg of weight of the biomass. Okay. If 1 kg of BOD is given, it produces 0.4 kg its weight. Okay. But here 219.6 mg per liter is given to bacteria. Okay. So biomass produced will be the sludge produced. So biomass or the sludge produced will be equal to 0.4 times 219.6 mg per liter. Okay. So if we see what will be the answer, can you tell me the answer, Bhupender?
87.84.
So it is 87.84. Let me check what is I'm getting. Okay. It is correct, Bhupender. Now you find the mass of the secondary solids produced. You know in mg per liter. So convert it into, this is
Yes.
in mg per liter. So mass of biomass produced. This is concentration, right? If you have to find the mass, then you have to multiply it by
8,
9 point, that ml,
9.52.
9.5. So just multiply and tell me mass
24.
of uh,
836.24.
836.24. Correct. 835 I'm getting. Okay. So now you apply this thing, the same thing in the formula. Okay. Now you know all the answers, right? Mass of this sludge will be equal to 835. Percentage is 1.5. Specific gravity is 1.02. I'll just write down. Mass of sludge produced is 835, right? 834 or 5. 835. Specific gravity is 1.02. 1.02. Percentage of solids is 6%. Now tell me the answer, Bhupender. Sorry, the percentage is 1.5, not 6. It is 1.5. Okay, now tell me the answer. Bhupender, what will be the answer? 835 divided by 1.02 divided by 1000 divided by 1.5 into 100. Bhupender, Punita,
It's 54.57.
it is correct. So now you have found the volume of the primary sludge and volume of the secondary sludge. So that was the thing that is asked in the question, right? See the question, primary and secondary sludge volume. So now you have found the primary and secondary sludge volume. This is how like you have to do it like practically. So since I had a live example, I just explained it with the help of that. Is it fine for both of you?
Yes, ma'am.
Punita?
Yes, ma'am.
Okay. Is it fine, Punita, or like you want me to explain?
Find out, ma'am.
Okay. Okay, da, okay. Okay. Thank you. Thank you so much. So now with this, the live session ends and I'll upload the PPTs and this recorded session also. If you still have further doubts, you can look into the recorded session and watch it multiple times to get it clarified. Punita, you can watch the recorded session. I will just upload in the YouTube and the link will be sent to you from the NPTEL support team as an email, so you can like look into that if required. So with this, I wind up this session and thank you so much for attending the session. If you have more doubts or something to be clarified, you can come in the last session. So that will be the last session for the entire this PPD live session, and with that the course will end. Thank you so much.
Okay,
Thank
thank you, ma'am.
Thank you.